Hello guys, welcome back to Everyday Kargil. So today in this lecture we are going to talk about RT-PCR. What RT-PCR stands for? Many people get confused between real-time PCR and reverse transcriptase PCR. Generally, RT-PCR is used for both of these PCR, real-time PCR and reverse transcriptase PCR. What are the techniques that used in real-time PCR and what is actually the reverse transcriptase PCR? The real-time PCR, or sometimes called as RT-qPCR. The RT-qPCR generally measures the amplification of DNA in real time using some fluorescence probe. But in reverse transcriptase PCR, it converts the RNA into complementary DNA, cDNA, before PCR amplification. The second one is the starting material. So what is the starting material in RT-qPCR? RT-qPCR real-time PCR requires DNA as the starting material. But in reverse transcriptase RT-PCR, we need RNA as the starting material and convert this RNA into cDNA before PCR amplification. So what do we target in the real-time PCR and RT reverse transcriptase PCR? In real-time PCR, we detect and quantify DNA targets, and in the reverse transcriptase PCR, we detect and quantify RNA targets. So these are the difference between RT-PCR and RT-qPCR and RT-PCR. So what are the various application of both of these PCR? Real-time PCR used to quantify DNA levels. Sometimes we use it to identify gene expression, how much the gene is expressed, and detect mutations and diagnostic some genetic diseases. But the reverse transcriptase PCR we commonly used to study gene expression level, detect viral RNA, in COVID-19, most of the tests we used as RT-PCR test, and some in infection diseases like COVID, and analyze RNA viruses. So what are the various steps in reverse transcription step? Is the real-time PCR is not applicable for reverse transcription step, it is directly amplify DNA. But in RT-PCR, it required an additional step to reverse transcription to convert RNA to cDNA before amplifications. So how do we design a primer or design a probe? Is in real-time PCR we use specific DNA probes and primer to target the DNA region of interest. Which region we want to amplify, we may target probe and primers. But in RT-PCR reverse transcriptase PCR, we require primers specific to the cDNA, complementary DNA obtained from the reverse transcription steps. So let's talk about the quantification method. What do this qRT-PCR quantify and what does the reverse transcriptase quantify? So the real-time PCR generally quantifies each cycle based on the fluorescence, and the RT-PCR quantifies the amount of the cDNA at each cycle based on fluorescence. So what is the sensitivity and specificity of both of these PCR is generally, and the qRT-PCR is more sensitive than and it is specific to a target DNA, and the reverse transcriptase PCR is sensitive to the target DNA but required careful consideration, yes, to avoid some potential artifacts due to reverse transcription step. And let's talk about the data analysis. So in real-time PCR, we generally measure the cycle threshold that we call CT to determine the initial DNA concentration. And in RT-PCR, RT reverse transcriptase PCR, we generally measure the cycle threshold CT to determine initial RNA concentration, and additional analysis involved accounting for reverse transcription efficiency also. So what are the various advantages of this both of this PCR? Is the RT-qPCR directly measures DNA and provide accurate quantification, how much DNA is amplified on a specific time. And in reverse transcriptase PCR, it enables us to study the gene expression and RNA targets, which provide some valuable insights into the cellular process and about the genetic information of that infectious virus and other thing. So thank you so much for watching. We will I will see you all in my next lecture. If you haven't subscribed my channel, just subscribe it.